This is the 9.1 to 9.4 review. Number 9, calculators are allowed, and all three of these are dealing with Newton's law of cooling. So it helps if you can recall that we developed that Newton's law of cooling by realizing that the temperature difference, the rate at which the temperature was changing, was proportional to the difference between the two temperatures, the surrounding temperature and the temperature of the object. So when we solved that, we ended up getting the temperature was equal to the surrounding temperature plus the initial difference between the object and the surrounding temperature times e to the kt. So on this one we want to work with a hard-boiled egg. I was given you a temperature of the original egg and the surrounding temperature, and I told you it cools, so I've given you 2 points on that curve. So the first one is when time is 0, my temperature is 95 degrees. The second point that I give you is when time is 10, I have a temperature of 50 degrees. So we're going to use this first one to set up the original equation. The temperature will be the surrounding temperature, which is 20, plus the initial, which is 95, minus the surrounding, which is 20, times e to the kt. So that gives us that the temperature is 20 plus 75 e to the kt. So now we're ready to plug in the next point, which is the temperature is 50 when it's been in the running water for 10 minutes. So now if I isolate k, I would subtract the 20, then I would divide by the 75, then I'd log both sides, and then I would divide by 10. That gives me my k, which now enables me to write the equation that's true for all time. And if I didn't give the equation like that, I would have created a decimal. Oh, it looks like I did, so I figured out that decimal on my calculator, and I get e to the negative 0.092 times t. So part B works exactly the same way. We start with our initial temperature. When time is 0, we've got a 38-degree statue, and it's going to cool after 1 hour to 25 degrees. So we can use this point to write our initial setup, which is T equals the surrounding temperature plus the initial minus the surrounding times e to the kt. So that gives us a 12 plus a 26 e to the kt, and now I'm ready to plug in my second point. I end with the temperature of 25 after I've been sitting for 1 hour. So to solve for k, I would subtract 12, I would divide by 26, I would log both sides, and then divide by 1. So there's my k, which now enables me to write my t will be 12 plus 26 e to the log natural of a half times t, and again I found that on my calculator and ended up with a negative 0.693 t. Last but not least, suppose that an aluminum scooter is brought outside to a temperature of 32. So again, we have the initial temperature of 57, and then after 15 minutes we have a temperature of 42. So using the initial, I can get T equals the outside temperature of 32 plus 57 minus 32 e to the kt. That gives me a T equals a 32 plus, what is that, a 25 e to the kt. So now I can plug in my next point, 42 degrees after 15 minutes. I can solve for k by subtracting 32, dividing by 25, logging both sides, and dividing by 15. So I will get temperature is 32 plus 25 e to the 1/15 log natural of 2/5 times t, or I can get that off my calculator and estimate it as a negative 0.061 t. And we're done.